Video is going to be discussing our rotations. So section 3.3. So what is a rotation first off? Basically we are spinning a object around a point. So like we saw in the introduction to rotations video, we have a central point and we have, I'm going to call that point A, and we have a shape, which for our purposes, I'm just going to say is this point. And if I rotate it, let's say to here, and that rotation has a specific angle measure, which I'm going to call x degrees. So the way we denote this is r, lowercase, the degrees, and then the point that we're rotating around. So let's look at an example. Now we're going to rotate the quadrilateral 90 degrees, and we're going to rotate around the origin. So we are actually going to be performing r 90 degrees, comma, O. Just because that's their standard notation for the origin. So we're rotating 90 degrees. And if you recall, 90 degrees means that we're perpendicular. So if we tried to draw that for, like, let's say this first point, okay, we have that. And that's the line y equals x. The line that's perpendicular to it is y equals negative x. So that is where that point would end up. Let's look at one that isn't that perfect y equals x. So I'm going to erase this, and we're going to look at this coordinate. So this line is the line y equals 1/3 x. The line that's perpendicular to it is y equals negative 3x. So that would be up 3 to, well, up 3, left 1. So there's our 90-degree angle. Now, instead of finding all of these using that method, we're actually going to think about what just happened. This was the point 2, 2. This is the point negative 2, 2. So we have negative 2, 2, and we have 2, 2. This point, well, actually we'll start here. This point is the point 3, 1. And this point is the point negative 1, 3. I can go ahead and guarantee you that our next point is negative 1, 5. The next point is negative 3, 5. And this is our object. So that's kind of interesting. Let's look at these points. If we're rotating 90 degrees, this will always occur. A rotation of 90 degrees takes the point xy and sends that to the point negative y comma x. Every 90-degree rotation does this. Okay, well, let's look at a different rotation. Let's say that we are rotating 180 degrees. So this would be denoted as R 180 degrees, comma, O, because again, we're going to rotate around the origin. Well, if we go 180 degrees, that literally means we are taking this and we're moving it over here. In fact, this is the same as reflecting it about the line y equals negative x. So what we end up with here is this. Our rotation of 180 degrees, it is going to take every point x, y, and it's going to send that to negative x, negative y. So my point 2, 2 becomes, that's not 2. 2, 2 becomes negative 2, negative 2. 3, 1 becomes negative 3, negative 1. 5, 1 becomes negative 5, negative 1. And 5, 3 becomes negative 5, negative 3. Which, again, gives us this shape. Okay. There is one more rotation that we're going to look at here today, and that is a rotation of 270 degrees. Now, this is a denoted rotation, 270 degrees about the origin, because we are going to rotate about the origin. Which means this is basically being moved here. Now, let's think about this for a second. If we rotate this 270 degrees, that would be the same as rotating this 180. And if you remember, this one was negative y x for all of them. This rotation is going to take our x and our y, and it's going to map it to y negative x. So 2, 2 still is 2, negative 2. 3, 1 is 3, 3, 1 is 1, negative 3. 5, 1 is 1, negative 5. And 5, 3 is 3, 5. And those are the main rotations that we're going to deal with. The reason they're the main rotations we're going to deal with is simply because the others require us to use a compass and a protractor, which we can do, except we are trying to minimize sharing of tools given the current situation of everything. That is all for this video, and I will see you in the next one.